All right, today in geometry, we're looking at section 6.2, which are using proportions to solve geometry problems. So we're going to start out with the properties of proportions. So first, our cross products property. This is what we looked at yesterday. In a proportion, the product of the extremes is equal to the product of the means. So if A over B equals C over D, then when I cross multiply, this should say AD equals BC, as long as B is not equal to 0 and D is not equal to 0, since we cannot divide by 0. The second one is the reciprocal party. If two ratios are equal, then their reciprocals are also equal. Remember, reciprocal just means I flip it. So if A over B equals C over D, then when I flip both of those, I would get B over A equal to D over C. This time A and C could not equal 0. The next one, if you interchange the means of a proportion, then you form another true proportion. Remember the means, those are the two that are in the middle. So if A over B equals C over D, then B and C are your means, so interchange them, and then you would get A over C is equal to B over D, again, where C and D cannot equal 0. And the last property, in a true proportion, if you add the value of each ratio's denominator to its numerator, then you form another true proportion. So if A over B equals C over D, then A plus B over B equals C plus D over D, again, as long as B and D are not equal to 0. So we're going to use those four properties to complete these statements. So it says if 7 over 3 equals x over y, then 10 over 3 equals what? Okay. So the very first thing I notice is that I have a 10 in the new ratio. Okay. I did not have a 10 anywhere else. So the only way that I could have gotten a 10 is if I had added something. So if I notice that last one that we talked about, if I took and I added the numerator and the denominator, 7 plus 3 over 3, I end up with 10 over 3. So that's what they did. So they're using that last property. So 10 over 3 is going to equal, so I would do the same thing with the x over y. So the numerator plus the denominator, x plus y, over the denominator, y. Number 2, if x over 18 equals y over 32, then x over y, okay? So I started out with an x and y in the original one. So what did they do here? Y is one of the means. One of my properties says that I can interchange the means. So if I interchange the means, then that y comes below the x, which is what they gave me. The 18 would go up to the top, and the 32 would stay the same. So that would equal 18 over 32. Number 3, if 9 over x equals 11 over y, then 9 over 11 equals what over what? Again, what did they do? That 11 is a mean, and it came below the 9. So all they did was interchange those. So this is going to equal x over y. Number 4, if x over 7 equals 2 over y, then x plus 7 over 7, well, this is an easy one to determine what they are doing, right? Because it says x plus 7, okay? So it's equal to 2 and y, so I add those two together, 2 plus y over y. All right, so now using those same four properties, we are going to determine if the statement that they give to me is true or false. So number 1, if x over y equals 13 over 2, then x over 13 equals y over 2. Well, what did they do to get here? They changed places with the y and the 13. That's all that they did. Those are the means. So this is true because that is one of our properties, right? What they did was interchange the means. So that's true. You don't have to identify which property it is. I'm just doing that for your benefit. So that one is true. Number 2, if x over y equals 21 over 4, then 4 over x equals y over 21. So let's see, what did they do? They brought this 4 up to the top, but then put that x down to the bottom. We don't have any property that says that I can take my extremes and put on the same side together, right? So this is a false, because they took the extremes and put in the same ratio. And remember that cross product, my extremes would get multiplied together, and they did away with that. So that's going to be a false. All right, so now we're going to use the properties of proportions to write for true proportions. So they give me mn over rs, okay, equals np over st. So our four proportions, our four properties, the very first one is just going to be the cross product. Okay. So cross product, we're just going to write out this that they gave to me. So instead of mn, I come over here, mn is 8. Over rs, rs is 10. Equals np, np is 4, over stx. Okay. So there's my cross product. 8 over 10 equals 4 over x. Next, I'm going to do the reciprocal. The reciprocal just told me that I flipped these. So this would say 10 over 8 equals x over 4. The next one, we're going to interchange the means. So that means the x and 8 are going to trade places. So this would say 10 over x equals 8 over 4. Or I could have made that say 8 over 4 equals 10 over x. If I'd gone back to the original cross product one and interchanged the means. Then the last one we have is the add the denominators. So this is going to be 8 plus 10 over 10 equals x plus 4 over 4. But I'm not going to leave it as 8 plus 10, so I would work that out. 18 over 10 equals x plus 4 over 4. Great. So now we're going to use proportions with geometric figures. So we're going to use those properties to solve for some missing measurements or links. So this is the picture they give me. They want me to find b to a, which they have marked as x, and b to d. They have not marked b to d. Okay? They're telling me this is the proportion. So I'm going to see, can I just go ahead and use that proportion as it is, or do I need to use one of my properties? Okay, so b to d. I don't know what that is, but I know that this little part down here is 3. The entire thing is x. So let's say that I knew that this was 10, okay? That b to a was 10. If I did 10 minus 3, that would get me this, right? B to d. So I can use that philosophy to write out that b to d is really x minus 3. Now I have an expression for b to d that I can come over here and put in this ratio. So if I set up b to d, we just said b to d was x minus 3, over dA, d to a is 3, equals BE, so BE is 18, over EC, EC is 6. Okay. So now I have my proportion. All I have to do is cross multiply. So 6 times x minus 3, all that parentheses, equals 3 times 18. Distribute 6x minus 18 equals 3 times 18 is 54. Trying to solve for x, so add 18 to both sides. So then I get 6x equals 72. Divide by 6, x equals 12. So now let's remember, what did they ask me to find? They asked me to find b to a. So b to a is x. That's what I just found, 12. And it asked me to find BD, which we said that was x minus 3, right? So BD, if I do 12 minus 3, I get 9. The BA is 12, BD is 9. All right, let's try another one of those. This one, you should have a 28 here. It's got lost in translation somewhere. So we're looking for SR and UR. Okay, SR they have marked as X. Okay. UR, okay, If S to U is 8, again, same philosophy. If the whole thing is x, that part is 8, then this is going to be x minus 8. All right, so let's see. I have SV over VT. So SV over VT equals SU over UR. Again, I can go ahead and just set it up the exact same way, okay? So S to V is 12 over V to T, 28, is equal to SU 8 over UR x minus 8. Again, now I want to just cross multiply. So I would have 12 times x minus 8 equals 8 times 28. I need to distribute my 12 here, so I get 12x minus 12 times 8 is 96, equals 8 times 28, 224. I want to get x by itself, so I'm going to add 96 to both sides, and I get 12x equals 320. Divide by 12, so x equals 320 divided by 12. All right, that's not going to be a nice whole number, so I'm looking for what's the biggest thing that they both have in common. Let's see, it looks like 4 will go into both of them. So I get x equals, so 320 divided by 4 is 80. 12 divided by 4 is 3. So what am I looking for? First, SR. S to R is x. So S to R is my 80/3. Again, if you prefer, you could change that to a mixed number. Okay, no decimals here though, please. And then U to R, okay, so U to R we said was x minus 8. Okay, so it's 80 over 3 minus 8 over 1. I need a common denominator, so turn this into a 3. So this is really 24. So 80 minus 24 gets me 56/3. All right. Go to our last page of notes. Here we're looking at scale drawings. So it tells me that a scale drawing is a drawing that is the same shape as the object it represents. The scale is a ratio that describes how the dimensions in the drawing are related to the actual dimensions of the object. Okay, so it's scale over actual, and then it tells me we always divide to make a 1. Okay, we make it a 1 in the numerator if the units are not the same, in the denominator if the units are the same. All right, so we'll look at the very first one. A model train engine is 12 centimeters long. The actual engine is 18 meters long. What is the scale of the model? So I always use this scale over actual, right? So the scale, they told me, is the model train, right? So that's going to be 12 centimeters over the actual 18 meters. All right, so now, right, remember, I'm not trying to make them have the same units here because it's just asking me what's the scale of the model. So I know it's going to be centimeters to meters. The rule up here told me the units are not the same, so I divide to make a 1 in the numerator here. Okay, so what am I going to have to take the numerator 12 by? What am I going to have to divide 12 by to get 1? Well, itself, right? So I want to divide this by 12. But whatever I do to the top, I also have to do to the bottom, right? I have to do the same thing to everything. So on top, 12 divided by 12 is 1 centimeter. On the bottom, 18 over 12. I can reduce that. 18 and 12, they both have a 6 in common. So that will reduce to 3/2. And this is in meters. So the scale of the model, 1 centimeter to 3/2 or 1.5 meters, right? Because 3/2 is the same thing as 1.5. So on the model, right, every centimeter represents 1.5 meters on the actual engine. That's what that's talking about. All right, let's look at another one. Number 2, a street on a map is 3 inches long. Okay, the actual street is 1 mile long. Find the scale on the map. So again, we do the scale. Okay, so the map is 3 inches over the actual 1 mile. Again, I notice my units are not the same, so I want to divide to make the numerator 1. So 3 divided by 3 gets me 1. So divide top and bottom by 3. So on top, 3 divided by 3 is 1 inch. On the bottom, 1 divided by 3 is just 1/3. And here I have miles. So the scale on the map, 1 inch to 1/3 of a mile. So every 1 inch on the map represents 1/3 of a mile. All right, one more. A scale drawing of a cell phone has the length of the antenna on the blueprint as 5 centimeters. The antenna's actual length is 2 centimeters. What is the scale of the blueprint? Okay, so again, the scale over the actual. So the scale is 5 centimeters over the actual length was 2 centimeters. Now here, notice they're both centimeters, centimeters and centimeters. So I have the exact same units, so I divide to make the denominator 1. So here, what do I have to divide 2 by to get 1? 2. So I divide top and bottom by 2. So on top, I have 5/2 centimeters over 1 centimeter. So 5/2, okay, that's the same as 2.5. So 2.5 centimeters to 1 centimeter. So this time they made the scale drawing bigger than the actual object itself. Okay? So on the scale drawing, every 2.5 centimeters really only represents 1 centimeter on the actual cell phone. Okay, so here the blueprint drawing was actually bigger than the actual item itself. All right, so that is section 6.2. Your homework tonight is worksheet 6.2, doing all of the exact same stuff that we just did here. Also, don't forget that you need to be looking at your vocabulary for the vocabulary quiz on Friday. So Friday we will take a quiz over all the sections that we have done up to this point, along with the vocabulary. Remember, your vocabulary can be found underneath module chapter 6 or underneath January 5th's announcement.